In this video, we are going to solve a polynomial inequality. Let's start by solving and finding the x-intercepts as if this were an equation. So let us add 48 to both sides. If we do that, then what we have is 2x to the third power minus 3x squared minus 32x plus 48 is greater than 0. This is what we need to solve. But for now, imagine that this was an equal sign. So basically, just look at this polynomial right here. Because what we want to find are the x-intercepts of this polynomial. So we can get a basic sketch going. So let's use our TI-30XS multiview and type this in. So let's see what we have here. Let's see, can I move this over a bit? Good old TI-30. Hit the table button. Let's see, we don't need that right now. So 2x squared, no, 2x to the third power minus 3x squared minus 32x plus 48. Okay, let's look at the table. I did not mean to do that. I meant to just hit enter. Now I got to type it all back in again. Alright, back in business. I hit enter. Alright, it doesn't really matter where you start. I usually start at like -10 or so. Alright, and just hit enter until you get to the table. Okay, what I'm looking for is a 0 on the y side, because that will be an x-intercept. Okay, so there's one right there, -4. Let's write that down. So I'm just going to make a list of zeros. So we have one at -4. Now the degree is 3. That means there will be a maximum of 3 zeros. Alright, a maximum of 3. Okay, so I got one of them. So two to go, potentially. Notice that these are positive, so I'm sort of looking for it to turn negative or something. Okay, so see how it went from positive to negative? That tells me that there was a 0 right here, somewhere between 1 and 2. I don't know exactly what it is, but we'll have to find that one another way. But there's another one, 4. So I'll write that down, but I know I don't need to look anymore because the other one we saw it was between 1 and 2. We'll have to find it another way. So here's what we will do. Let's go ahead and use synthetic division to factor this down. So let's start with the -4, for example. So if I use synthetic division and I start off with my -4 and look at these coefficients. I have 2, -3, -32, and 48. Alright, if I do synthetic division, I should definitely get a 0 remainder right now. So let's make that happen. Alright, so this comes down. 2 times -4 is -8. That's -11. Times 4 is positive 44. So that's going to be 12. And 12 times -4 is -48, which does give me 0. Okay. Now I have another 0, so I could use it again, and I think I will. I know another 0 is 4, so I'm going to keep on going. Maybe I'll change colors a little bit. but now I'm going to use my 0 of 4 to make this smaller. Okay, so if I do that, then what I'm going to have is this 2 is going to come down. 2 times 4 is 8. Negative 11 makes negative 3. Negative 3 times 4 is negative 12, and again I get 0, which I knew I would. Okay, so here's what's left of my polynomial. So I know that basically if I were to factor this thing, okay, see that negative 4? That means x plus 4 is a factor. See this positive 4 right there? That means x minus 4 is a factor. Now see the rest of this stuff right here? If I put my x in, it would go right there. So that means 2x minus 3 is my other factor. So basically I just factored this polynomial is the same thing as this in factored form. So my 2 zeros came from the x plus 4 and my x minus 4. My third mystery 0 is going to come from this guy. If I set this guy equal to 0 and solve, it's pretty obvious what happens, right? 2x minus 3 equals 0. If I add 3 to both sides, right, that's going to give me 2x equals 3. If I divide both sides by 2, I guess I'll just go ahead and do it. That's going to give me x equals 3 over 2. Or 1.5. Okay, so I've got my 3 zeros now. I've got negative 4, positive 4, and I've got 1.5. What was the point of that, you say? Well, the point of that was now I can make a basic sketch of the situation. So here's what's happening. I feel like I'm running out of space. So I'm going to do this on the black screen. Right, the black screen is basically my scratch paper. So remember, I had the zeros that were negative 4, 1.5, and positive 4. Okay, so if those are my zeros, then when I do my sketch, it might look like this. So let's see, negative 1, negative 2, negative 3, negative 4, so there's negative 4. Okay, here's 1, here's 2, here's 3, and here's 4. Okay, so there's 1 and 2. So look at this. I have these 3 zeros. So I have a 0 at negative 4, I have a 0 at 1.5, and I have a 0 at positive 4. Okay, now looking back at this thing, this is a cubic polynomial with a positive leading coefficient. So I know it's going to be making this sort of an N shape. Okay, because that's what cubics do. Capital N when it's a positive leading coefficient. So it's doing this type of thing. It's going like this, and like this, and like this. Alright, so this is what the graph is doing. Now remember what we're looking for. We're trying to find where is the polynomial greater than 0. Now when you see that word greater than, you should be thinking above. Right? Greater than 0 means above 0. So what part of this graph is above 0? In other words, above the x-axis. Well, take a look, people. This is the part that is above 0, above the x-axis. It's above from here to here, and then it's above here. Okay, so this white that I just drew represents the solutions. Now notice I do not want to include the endpoints. Alright, because that's where it equals 0. And it doesn't say or equal to 0, just greater than. So I want to carefully leave out the endpoints. So It's like doing an open circle here. Alright, we don't want to include the endpoints right now. So how would I describe this? Well, in interval notation, here I have solutions from -4 to 1.5. So I would say -4 to 1.5. Okay, that's awfully big. Let me tone down my ink going wild over here. Go back to normal size. So -4 to 1.5. And I'm going to use round parentheses to show that I'm not including the endpoints. And then this other solution area, this other part of the graph that's above 0, above the x-axis, starts at 4 and then goes to the right forever. So I'm talking about 4 to positive infinity, again with the round. And in between here I just put a union symbol to show that I want all of this connected. So that is going to be my final answer. Alright, so you really have to make this graph in order to answer the question.